the first thing you need to know for question 1 of review sheet I is, when is a function concave? A function is concave when the second derivative is less than 0, and it convex when the second derivative is greater than 0. Other reasons as well, but they're the two things that we're looking for. So if we've got f of x for the first one, as this bit here, when I differentiate that, I'm going to get 6x squared minus 8x. When I differentiate it again, I'm going to get 12x minus 8. And 12x minus 8 is less than 0 when x is less than 2/3, 8/12, or when x is less than 2/3. So it's all the way from minus infinity, I suppose, all the way up to 2/3, and when x is greater than 2/3, it is convex. I'll do b as well. So part b, again, if I differentiate that, we're just going to get minus 4x plus 5, and the second derivative is minus 4. So it's always negative. So that means it's always concave. And you know that. You know that because it's an x squared graph. X squared graphs are always concave, don't they? They don't suddenly turn around and start going the other way. So that's that. Parts C and D, well, you've just got more difficult differentiation to do, haven't you? So for part C, differentiating sine 2x goes to 2 cos 2x, and differentiating it again is going to make minus 4 sine 2x. And when is that less than 0? Well, so just make that equal to 0. It's equal to 0 at these places here, so it's less than 0 between those two, and it's more than 0 between those two there. And part D, I've got another one of those like the last review sheet, having to find what in the inverse cos differentiates to give. I'll tell you, it differentiates to give that. You could have found that in your notes, and if you differentiate that a second time, so now you're going to have to use a quotient rule to try and differentiate that a second time, then we get this. That's cubed, isn't it? And when does that work? So it's well, I'll leave you to work that one out.